Lesson 5.10, Quadratic Forms. This is where we're going to talk about the three different ways that a quadratic equation could look. There's the first one, standard form, we're the most comfortable with. That's our ax squared plus bx plus c. I think standards are like your ABCs. This form can easily tell us what the y-intercept is. So you will not have the graph on Delta Math. You'll just have an equation. And I think this one even says, like, they want you to find the y-intercept, which form should it be in. Choose that you want it in standard form, then a function will pop up and you have to find it. So let's think about any kind of y-intercept. That means that point is on the y-axis. That means its x value is 0, comma, whatever number it has for the y value. So x is always 0. So how we would find that is say, okay, this is really a fancy way of writing a y. We want to plug in a 0 every time we see x. And you'll get to where you don't even have to do this, because 0 squared 0 times negative 2 is 0. Negative 16 times 0 is 0. That just ends up being negative 14. And I don't remember if they want it as an ordered pair or not. I think so. So when x was 0, we were able to get out negative 14. It's really always going to be just this constant number that does not have x. And then here's what the graph of this looks like. And so you can see right here, there's the y-intercept at 0, negative 14. All right, then we have factored form. Factored form is like what you were doing with factoring in the last unit. It has things getting multiplied together to make some kind of something squared. And so what it's good for is finding x-intercepts. When we're solving these, remember making each factor set equal to 0. So this is just a number equal to 0. That's not possible, so that's not an answer, but this would be x minus 3 equals 0. Add 3 to both sides, so that's one answer. X plus 1 equals 0. Subtract 1 on each side. X equals negative 1 is an answer. And so that's what you would have as the roots. They may have you have them as ordered pairs. I don't remember. So it'd be 3, comma 0 and negative 1, comma 0. So kind of cool to see how a y-intercept x is 0 and the roots or the x-intercepts, the y is 0, because these points are here and here on the x-axis. So that's like you're setting this equal to 0 and then solving each factor. So if they ask for x-intercepts, pick factored form to find them the fastest. And then the last one that we're not as familiar with is called vertex form. Vertex form is your a is in front of x minus some number squared plus or minus a k on the end. H comma k is the vertex. But notice how there's a minus sign in front of h. That means that if h is a positive number, it's going to be minus that number. If h is a negative number and you plug it in, it's going to be minus a negative, which turns into a positive. So this one is always the opposite of what it looks like. So I'll put that. The h is always opposite of what it looks like. Okay, so in this problem, again, you would not have this graph. If it asks for the maximum or the minimum, it's only wanting its y value, does not need an x value with it. So let's think about a quadratic. If I have one that opens up, its vertex would be considered the minimum. If I have a parabola that's opening down, the vertex would be the maximum. So seeing this number in front is going to help me know what I'm finding, for one. So this is positive, it's going to open up. So I'm going to be finding a minimum. Okay, I want to find the vertex by just pulling it out of here. So remember we said that this is x minus whatever the number is. So the x value that got plugged in there is simply 3. And then this number on the end is negative 50. It actually means that it went down 50. So our vertex is at positive 3, comma negative 50 right here. They, though, want just the minimum, which is the y value. So the minimum would be the negative 50. That's the lowest this graph will go. Okay, the other thing it's going to want you to find is increasing and decreasing. That's the x values only. So think about reading this graph from left to right, like you read words on a page. You're riding a roller coaster, ignore this arrow. You're going to go down to here, and then you're going to change direction, you're going to go back up. So we are decreasing for x values that are less than this x value of 3. Okay, so see how this is here. So when x is negative 10, we're decreasing. When x is negative 5, we're decreasing. When x is 0, we're decreasing. We're decreasing for all these x values until we get to this minimum. Then we change directions and we increase when x values are greater than 3. So your turning point is happening here at the vertex. So you're looking at its x values and comparing to really this number line is what you're looking at. So hopefully that makes sense. If not, make sure you're asking questions.